we had to design an experiment and extract soil columns from the ground, bring them to our lab, set them up, and run effluent through them like we were actually creating a tiny wastewater treatment system and dispersing that effluent back into the ground.
This is an experiment that the state of Vermont indirect discharge program requested we do. It's because we've got a wastewater dispersal site that we're working with the state and another engineering firm to develop in the village of Montgomery.
If you are trying to get a system permitted with a design flow of over 30,000 gallons a day and a soil-based wastewater disposal system, you have to be able to demonstrate that the soils at that particular site can accept those the renovated effluent that you're going to load into it from a leach field.
We harvested these soil columns from Montgomery by drilling the pipes into the ground so that the soil didn't get mixed, and you can see the grass is still growing out of the top.
Soil texture and structure is important. That's why we wanted to get relatively large soil columns so we could sort of reproduce that, really, how wastewater would percolate through these columns in the real world. We got some heavy-duty PVC pipe and contracted with a geoprobe operator just to pound these things in the ground and then extract them.
And then we collected wastewater, secondary plus effluent from Hyde Park. So that's after it's gone through the treatment process, right before it's sent out into the leach field, basically.
The main thing we're trying to look at and demonstrate is that phosphorus is retained within the soil column.
I pump it out of the tank there, bring it back, put it in the fridge, and then every hour for about 5 minutes and 40 seconds, this pump over here turns on and the wastewater gets pumped through this tubing and goes into the soil columns. Each soil column has a special type of tubing that has one hole in it, and it has a specific rate that it drips out of that hole. And then the water just drips through the soil and we collect it in these buckets.
We're planning to load them about 2.7 gallons per day per square foot, which is a relatively high rate, and we think the site is suitable for that, can certainly accept that.
For me, it's a lot of spilling water. Basically taking the 5-gallon buckets and pouring them into a graduated cylinder and then filling up sample vials with the graduated cylinder.
What it would suggest is that on a favorable site, like this Montgomery site, and using drip dispersal, we can load soils at a higher rate than is currently allowed.
It's hard to do that site-specific test, and so they tend to not do it. They tend to design a system that's 30,000 gallons a day or less. The exceptions are mostly ski resorts or big developments.
This was an opportunity to do something that, while it's not field scale, we're trying to go large enough with these soil columns and with the wastewater flows that we're probably better representing field conditions, actual conditions, than most sort of laboratory studies. So I can imagine doing some of these types of studies on a range of soil types, and maybe that helps the state understand what different technologies might be permittable in other areas that don't have the benefit of these very coarse textured soils.